Hi everyone, this is D. Prakash, and today I am going to take the topic free body diagram and analysis of beams. As far as I am concerned, I am doing my ME Civil Engineering from ISC Bangalore and have secured GATE rank from Civil Engineering itself with All India rank 267. I did my BTech honors from NIT Raipur. So let us move on towards our own topic. Means our topic for today's discussion, that is free body diagram first. So in the figure you can see that a man is continuously lifting some weight to pump up his muscles. As we all know that everything in the world, if is static, then it is in equilibrium. So what does an free body diagram does? It is basically a tool which divides the whole body into smaller parts, smaller elements, so that we get very easy analysis. So basically we can say it exposes all the internal reactions along with external forces or moments applied on element under consideration. So it is nothing but a simple tool which eases the things for us. For example, let us take this problem where a man is trying to lift up some weight so that he can get some muscles like John Abraham or Hrithik Roshan. Again, there is one problem. When you are going to set up this weight lifting mechanism for yourself, then you should know that how much strong this wire should be, otherwise you will end up hurting your own leg. So let us see how the free body diagram works. In the first, so we can say that free body diagram can be converted into three components. Means any system, or rather I will prefer to say this system, where this man was trying to lift some weight through a pulley, can be broken into three parts. First one will be the weight, this weight itself. The second one will be the pulley system, and the third one will be where he is applying the effort, which is the rod system. So let us see how we can do it. First thing is, we have broken it into three components. As I have already said, the weight to be lifted, say its weight is W, which will be given to us obviously. The second part will be pulley part, and the third part will be man. So we can see, the weight is, instead of going down, is going up. So there must be some extra force which is coming on the weight, which is nullifying its own self weight. So hence we take an opposite reaction force in the string. We can also call it F. We are denoting it by F, or you can also denote it by T1. So since it is string, complete string extending till the pulley, so the force in the whole string, means tension in the whole string, will remain same. So this is the pulley, which is our next component, and here, since the string is same circulating over the whole pulley, the tension force remains the same, that is equal to F. And as I already told you that you have to hang your pulley through some rod so that the pulley itself doesn't fall. So that is why you will require one T, which is again another force, and you are again doing some exercise so that you can pump up your muscles. So obviously you are applying some force, which is F, as shown over here. So you can see this whole problem has been changed into very simple three components, and we can very easily use now equilibrium conditions so that we can find out what is the actual work done by us and what is the strength of string required to tie up this pulley. In every structure, you can simply use this principle to simplify the structure and analysis. So next, moving towards our next topic is, let us try one question. It is for you. Just pull out your copy and pencil or pen and try this problem. Here you can see there is one weight W1. Assume that here the friction working has a friction coefficient of F. Here one W2 is trying to pull this down, so obviously there will be some tension into this. So try to figure out its free body diagram. You have got 30 seconds for this. Okay, so I am now revealing the answers. Get ready. 1, 2, 3. So here we go. See, as I already told you, it simply enlists all the forces acting on a body. So here on this body W1, gravitational force is working. At the back side there is one frictional force working, which has magnitude equal to F into W1. Yeah, one more thing, remember it is vectorial representation. So it is very necessary that you make sure that vectors proper direction have been chosen. Here string will be pulled by, let us assume, T. W2 will be again pulled up by T because it is again in equilibrium. So if you apply the equilibrium conditions, then obviously your means T will be equal to Fw1, and there will be one reaction force from the table which will be equal to W1, and so on. So now you can apply the equilibrium conditions to solve the whole problem. Okay, so now let us move on towards our next topic, which is analysis of beams. In this I am expecting you that you know basics in the sense introduction of structural analysis, like what is the flexible method, what is the stiffness method. If not that, I will introduce it little later. But you should know what is indeterminacy in any structure. It is usually covered up in means introductory part of structural analysis. So we will cover that later. This is just a demo video. So let us first define a beam. What is the beam? The structural member whose predominant resistant mechanism is through bending. So bending action is the predominant mechanism. What does that mean? It doesn't tenses, it doesn't compresses, it resists the whole force exerted upon it, external forces exerted upon it through the bending action, which is like this. So there will be some assumptions as well, which we will deal later. So beam can be well represented as line element. It is usually taken as 1D element for ease of our analysis, and it is very well valid as well. So now, as I have already told you that you should know the determinate and indeterminate structure in order to analyze the beam. So let us first classify the beams, or we can say that let us check out the major types of beam based on this determinate and indeterminate structural members. So simply supported beam, that is the determinate structure. In simply supported, at one end we have hinge support, at other end we have roller support. Cantilever, one end is fixed and another end is free. Overhanging beams, some part is overhanging, that's only condition. It is same to simply supported, that is also a determinate structure. Indeterminate beams, propped cantilever, continuous beam, we will see the problems later on as the course proceeds. Okay, so the next thing is analysis of determinate beams. Analysis of determinate beams. So I have just jotted down it in 4 steps. First thing is draw free body diagram, FBD. Second thing is work out reaction forces using equilibrium conditions. The third step will be find out shear force and bending moments. And the fourth final step will be draw shear force bending moment diagram with denoting the maximum values. Now, till now I haven't dealt with shear force and bending moments. See, these two are the characteristics of the bending mechanism of resistance. If anyone asks you what do you mean by the bending? The bending means that the member is having some shear force and some bending moment in response to the forces, external forces applied to it. So now shear force, let us see what it is. First let us try to feel it, what it is. It is physical meaning is resistance offered by a section against the vertical split. Like over here you can see, let us suppose I put some force at this point. So it will, this section, this split section will try to pull this section down, while this section will try to keep it up. As long as it is in equilibrium, both the forces will be equal at this junction. If it fractures, then obviously it will shear. means it is splitting parallelly to each other. So mathematically it is sum of all the vertical forces on either the left or the right of the section under consideration. Either the left means either the left. You will consider only all the forces on the left, acting all the forces acting on the left, or all the forces acting on the right. We will see one example, then the mathematical expression will become much more clearer to you. So the next I was telling you the bending moment, bending mechanism. So here you can see just the mechanism. What is the actual mechanism? One part above the neutral axis will always be in compression, other part will always be in tension. So due to this bending moment, correct? So bending moment again physically means that it is the resistance offered by section against bending or tendency to avoid curve deflection. So it will become curved, and in that process it will generate some resistance. So mathematically we can say that it is sum of all the moments on the either left or right of a section under consideration. So as I have already told you that I have jotted down it in 4 steps. First draw a free body diagram, then reaction, then shear force and bending moments, and then shear force bending moment diagram. Draw this diagram. So let us try one problem. This is my beam where I have taken A is equal to L by 2. First I will draw one FBD as shown in the figure. This is hinge support. Hinge support means one horizontal reaction will come, one vertical reaction will come. This is roller support. That means there is no horizontal reaction, only vertical resistance is there. So R2 is there, F is already there. Yeah, this length is L1. So R1, R2, H are the reaction forces. A, C, B are the just the points. So step 2, find reaction forces using equilibrium conditions. So now as I have jotted down all the equilibrium condition in one of my prior slide, summation H is equal to 0 means all the horizontal forces, summation of all the horizontal forces is 0. Hence we can see here only one single horizontal force is there. So H plus 0 is equal to 0, hence H is 0. This is nullified. There is no meaning of this into this system. Summation of V is equal to 0 means all the summation of all the vertical forces is equal to 0. This implies R1 plus R2 is equal to F. R1 is acting upwards, R2 is acting upwards, and that is equal to F, which is acting downwards. Next is sum of all the moments is 0 means here I have taken the moment about A, which means the all the forces passing through A will give 0 moment as vertical distance is 0. So this implies R2 into L. R2 into L, which is giving me anti-clockwise moment, is equal to F multiplied by L by 2, which is giving me clockwise moment. So using this equation 1 and 2, we can find that R1 is equal to R2 is equal to F by 2. So now the major thing is finding shear force and bending moments. Remember, there is one sign convention. Whenever you are approaching from the left, so consider this upward force as positive shear and downward force as negative shear, negative value. Positive upward means upward force. Whenever you are approaching from the left, upward is positive while downward is negative. When you are approaching from right, the downward will become positive and upward will become negative. So remember any one of the diagram, you can deduce the other one. Shagging and hogging. There are two things. Whenever it is cantilever, you will find hogging, that is negative bending moment. And whenever there is simply support, you will find positive bending. So that is shagging, that is positive. In our case, it is positive bending, that is shagging. Here also you can feel that the curve will be like shagging, similar to this. So now from left I am considering SF is equal to F by 2 and bending moment is equal to FL by 4. So F by 2, I am considering shear force at C. So from the left hand side AC, for section AC, it is F by 2 for the whole section, which has been shown in this figure. While the same thing applies for the section BC from the right hand side, which is negative F by 2. So here you can see I have put it negative F by 2. Again this bending moment you can see from the left I have considered, which is giving a positive bending like this, right? So it is F by 2 multiplied by L by 2 is equal to FL by 4. Hence this is this